In this lecture, we are going to discuss some more example on complex integral. Evaluate integral c fz dz where fz is given by y minus x minus 3x square I, and c is the curve number 1 9 segment joining z equal to I, z equal to 0, z equal to 0 to z equal to 1 plus I. Number 2 consists of two lines, one from z equal to 0 to z equal to I, and other from z equal to I to z equal to 1 plus I. Solution: we have fz is equal to y minus x minus 3x square I. Number 1, equation of the line joining z equal to 0 to z equal to 1 plus I is, here we have to evaluate integral fz where fz is given by this function y minus x minus 3x square I along line segment joining z equal to 0 to z equal to 1 plus I. In next consists of two lines z equal to 0 to z equal to I, and other line from z equal to I to z equal to 1 plus I. First, we are going to evaluate the integral along the line segment joining z equal to 0 to z equal to 1 plus I. If you draw this, it is z equal to 0 and z equal to I will be some 1 1 1. So if you draw the line, this will be your this line is y equal to x. Okay, if you join this line, you will get y equal to x. This implies dy equal to dx. We know that z is equal to x plus iy. This implies dz is equal to dx plus I dy. Since dy is equal to dx, I replace it by dx I dx. So this is equal to 1 plus I dx. This implies dz is my 1 plus I dx. X varies from 0 to 1. Y also varies from 0 to 1. Varies from 0 to 1. Here xy is 0. xy is 0. Here xy both are 1. So x varies from 0 to 1. Therefore, the integral become complex integral fz dz over the curve C become 0 to 1. Now we will put y minus x minus 3x square I dx. Dx will be my 1 plus I. 1 plus I 1 plus I dx. dz is now 1 plus I dx. And this y will be equal to x minus 3x square I 1 plus I dx. This x cancel out. Here you should write since y is equal to x. In next line it will be 0 to 1 3x square minus will come outside, then it is I 1 plus I dx. So minus I 1 plus I will come outside. This is 0 to 1 3x square dx. This is equal to minus I 1 plus I. This is 3x square by 3. It is 0 to 1. This cancel out. This is equal to minus I 1 plus I x square 0 to 1. So this value, this is equal to I 1 plus I, and this is equal to, this is minus I minus I square, which is equal to minus 1 minus plus, this will be 1. So this is 1 minus I, 1 minus I, 1 minus I. 1 minus. Now we are going to solve the second part. Along the line z equal to 0 and z equal to I, we will x equal to 0 and y varies from 0 to 1. This implies dx is equal to 0. We know that z is equal to x plus iy. So this is equal to dz. This implies dz equal to dx plus ity. So this will give you dz equal to I dy. Therefore, fz dz over the curve C will be given by, here y varies from 0 to 1. My function is y minus x minus 3x square I. In place of dz it is I dy. But x is 0, so this portion will be 0. So here I will, in the next line we will get 0 1 y, I will come outside dy since x is equal to 0. So in the next line it will be equal to I 0 to 1 y dy, is it? And this is equal to here I y square by 2 0 1, that is I by 2. Here in case of second part we have two lines, one along z equal to 0 to z equal to I, other z equal to I to z equal to 1 plus I. So again along the line z equal to I to z equal to 1 plus I, x varies from 0 to 1, y is constant and y is 1, the x varies, y is 1 y is equal to 1. This implies dy is equal to 0, so that z equal to x plus I y may come now dz equal to dx plus I dy. Since I dy is 0, so this is equal to, this implies dz is equal to dx, since dy is equal to 0. Therefore, integral c fz dz will be my integral 0 x varies from 0 to 1, 0 to 1, and here we have y minus x minus 3x square I dx. Here y is 1 minus x minus 3x square I dx. So integration of 1 is x square by 2 minus 3x cube by 3. These are definite integral, so put 0 and 1. Here it is I, so it is 1. This is equal to 1 minus half minus 3I. Okay, 3 cancel out, 3 cancel out, this 3 cancel with this 3, so this is only I. So this is half minus I. Therefore integral of fz dz will be equal to, give this I1, is equal to I, first is I by 2 plus 1 by 2 minus I. So this is 1 by 2 minus I by 2. You can put here this I1, okay, I1 for the first value I1, then for the second value is I2. Therefore, integral of this will be my I1 plus I2. That is integral along the two lines z equal to 0 to z equal to I, and z equal to I to z equal to 1 plus I is the sum of these two integral, and the value is 1 by 2 minus I by 2. With that, I would like to conclude. Remaining will be in the next class.